Welcome everyone. Let's study ionic compounds today, and this is from lesson Metallurgy, part 4 video of this lesson, and this is for class 10 SSC. So let's begin. Alright, first of all student, what are the ionic compounds? So an ionic compound is defined as a compound formed by the oppositely charged ions, that is cations and anions, which attract each other to form a chemical bond. For example, sodium chloride, that is NaCl. So these are the ionic compound. You can see here the reaction between sodium and chlorine. So student, in the outermost shell of the chlorine, it is one electron, so it will easily donate one electron to chlorine. So here sodium is a metal atom and chlorine is a non-metal. Okay, so sodium will lose their electron and chlorine will gain the electron, and due to this cations and anions are formed. That is, after losing one electron, sodium becomes sodium ion, that is positively charged cation, and after gaining or absorbing one electron, chlorine will become Cl minus, that is negatively charged anion. So these are the ionic compound, cation and anion, that is Na plus Cl minus. And the compound which is formed due to these oppositely charged ion, it is called as a ionic compound. Now here the compound formed from the two units, that is namely cation and anion, are called as the ionic compound, and the cation and anion being oppositely charged, that is positive and negative, there is an electrostatic force of attraction between them. So due to the oppositely charged attraction of a oppositely charged ion, electrostatic force of attraction will be there between two atoms. And you know that this force of attraction between cation and anion is called as the ionic bond. Okay, so this is the ionic bond which is there in between two oppositely charged ions, that is Na plus and chlorine minus. So this is an ionic bond. And the number of cations and anion in a compound and the magnitude of the electric charge on them is such that the positive and negatively charged balance each other, and as a result an ionic compound, that is NaCl, will be electrically neutral. So this is all about ionic compound. Alright, so ionic compounds are crystalline in nature, as you can see below the diagram in the background, the crystals of a ionic compound. So these are formed in crystalline nature, and the surface of all the particles of a crystalline substance have a definite shape and are smooth and shiny, and the regular arrangement of ions in the solid ionic compound is responsible for their crystalline nature. So you can observe the alongside, and it is NaCl diagram. Okay, so here the particular proper arrangement is there, that is after positive and negative ions there is a proper arrangement is there, and proper arrangement of this cation and anion will give the ionic compound a crystalline structure or nature. And the arrangement of ion is different in different ionic compound, and therefore the shapes of their crystals are different. And the main factor that determines the general arrangement of ion is a crystal is the attractive force between oppositely charged ions and the repulsive force between similarly charged ions, it is electrostatic force. And because of this, the general crystalline structure has negative ions arranged around a positive ion, and positive ions arranged around a negative ion. You can observe the alongside diagram, that is after particular positive ion, it is surrounded by the negatively charged anion. So cation is surrounded by the negatively charged anion. So this is the structure and proper arrangement of ions in the ionic compound. Okay, so the two of the important factors responsible for a certain crystal structure are as follows. That means these two factors will determine the crystalline structure of the ionic compound. And first is size of the positively and negatively charged ion, that is size of the cation and anion. And second factor is the magnitude of electrical charge on the ions, that means the amount of electrical charge on the cations and anions. So these two are the main factor responsible for the crystalline structure of the ionic compound. And the electrostatic attraction, so the electrostatic force of attraction between the positively charged and negatively charged ions in the neighboring ions with opposite charges is very strong, and that is why the melting point of ionic compounds are high, and also the ionic compounds are hard and brittle. Okay, now next we have to study the properties of ionic compounds. Let's study. Okay, so here we have to look one experiment for the conductivity of salt solution and when we heat the salt solution. So let's see two different experiments. So first, for the experiment we required the apparatus like metal spatula, just to keep the salt solution over the spatula, and burner, carbon electrodes like graphite, and beaker, cell, lamp to check the conductivity of the electrical salt solution, and press key or switch and electrical wire just to join the proper circuit, all the electrical component in circuit, etc. And the chemicals we required for this experiment is samples of sodium chloride, that is NaCl, and potassium iodide, that is Ki, and barium chloride, that is BeCl2, and we required water to make the solution of salt. Okay, now here heating a salt sample on a spatula. So student, here we have to observe, we have to keep all the samples of the salt over the spatula and we have to heat it, and place the sample of one of the above salts on the spatula and heat it on a flame of the burner, and repeat the procedure using the other salts also as shown in the diagram. Okay, now after this, when we heat the salt solution, when we heat the salt sample over the spatula, what happened? When we heat the salt, it melts and then vaporize. But student, for these physical changes, it require very high temperature, that is 800 degree Celsius. Okay, so in normal condition, it only changes the color. And next we have to assemble the, that is here this spatula we have to keep the salt like sodium chloride, potassium iodide, and barium chloride. And next procedure, we have to check the conductivity of salt solution. For this, the setup is like this, that is two graphite rods are there. Assemble an electrolytic cell by using the beaker and containing the carbon electrode to the positive and negative terminal of the cell. You can observe the battery having negative and positive terminal, and lamp just to check the conductivity of salt solution, and switch is there, and beaker it containing the salt solution, and the graphite's rod are inserted in the salt solution. So student, after all the setup, so these are the graphite rods, and after all the setup we have to check, dip the electrodes in the salt solution of any one of the salt. That means whether we can take the sodium chloride also, potassium iodide, and barium chloride, any of the salt we can take, and we will make the solution in water. Now what happened? Do you see the lamp glowing? So when we put the graphite rod in the salt solution, what happened? The lamp will glow. That means the salt in the aqueous form only, it will conduct the electricity. Why? Because this ions, that is positively and negatively charged ion, will move from one electrode to another electrode, and it will conduct the electricity only in the aqueous solution of the salt. Okay, alright, so this is the experiment, and next we will study the general properties of ionic compounds one by one. So first property is the attractive force between the positively and negatively charged ion. That positively means cation and negatively means anion. Charge is strong, therefore the ionic compound exists in solid state and are very hard. So these are the crystalline structure, and the ionic compound are brittle and can be broken into pieces by applying pressure. That means when we apply pressure by anything, it will break down into pieces. And third property is the intermolecular force, that is the force between the molecules, okay, like cations and anions of attraction is high in ionic compound, and large energy is required to overcome it. That means to break the molecules, the forces are very, energy requirement is very high, because the intermolecular force of attraction between that molecule is very strong, and therefore the melting and boiling point of the ionic compound are high. Alright, now fourth one is ionic compounds are water soluble. and this is because the water molecules orient in a particular manner around the ions separated by the dissociation process. Dissociation process, that means when ions are dissociated, that is sodium will be, that is Na plus and Cl minus, and as a result of this a new force of attraction is established between the ions and the surrounding water molecules, replacing the original intermolecular attraction. An aqueous solution, that is the water solution of ionic compounds are formed, and ionic compounds are however insoluble in solvents like kerosene and petrol. So student, solvent is like a water, like it is something in which the salt can be easily dissolved. And so salts are not soluble in kerosene and petrol, and this is because unlike water, a new attractive force cannot be established in these solvents like kerosene and petrol. Okay. Now next property is the ionic compound cannot conduct electricity when in solid state. So student, just now we have seen in previous slide that in aqueous solution, that is salt solution only, aqueous solution of salt only conduct the electricity. Why? Because in aqueous solution the ions or cations and anions are movable, able to move. And okay, in this state the ions cannot have their places, and however in the fused or molten state they can conduct electricity, as in this state the ions are mobile, that is in aqueous solution. And the aqueous solution of ionic compound conduct electricity as they contain the dissociated ions. That means the ions can be separated, that is by this water, and on passing the current through the solution the ions move to the oppositely charged electrodes, and due to the electrical conductivity in fused and dissolved state the ionic compounds are called as electrolytes. Alright, so student, that is all about this video. I hope you all have understood, and next part of this lesson we will continue in our next session. Thank you.